Assalamualaikum and a very good day everyone. We are from group KA45 and this is our presentation for final year projects. And our title for this final year project is Compressibility Behavior of Batu Pahat Soft Clay Treated by Combination between TX85 and SH85 Progress Stabilizer. And this is a KA45 group member, and our supervisor is TS Ahmad Akimi bin Matno, and our leader is Nur Shazwi Wafi bin Muhammad Noor, and other two member is Irfan Fauzal Ahmad bin Nur Faizal and Muhammad Aisha Aidit bin Muhammad Azlan at Atan.
Before delving future into this project, I will tell a little introduce about our project. This research actually discuss the general construction problem at the Batu Pahat Road and the suitable probate stabilizer that can be used to overcome various kind of issues regarding to the construction of the road. This is because every road or highway should be constructed in a way that guarantees ensures comfortable, convenient, and most importantly, safe for people. Stabilization of the soil is very important in the construction to ensure the stability of the strength of stiffness of soil for each building to be constructed. There are many stabilizers that are used, which are divided into traditional and non-traditional. If a moist clay is subject to moisture and air may be expelled, resulting in the reduction in volume that is not immediately recovered when the load is removed. This will cause the soil in an area to be unstable. In road construction, a high amount of clay in the bitumen extraction process may cause the excessive bitumen emulsion into tiny droplets, resulting in a low bitumen recovery. Construction of roadways over the soft subgrade is one of the most common problems from the highway construction. The usual approach to the soft subgrade stabilization is to remove a soft soil and replace it with a strong material of crushed rock. The high cost of replacement caused highway agency to evaluate alternative method of highway construction on the soft subgrade. Next, road in Batu Pahat district experience many types of failures such as cracks, large surface deformation and structure deformation of pavement layers and the subgrade. Research Center for Soft Soil has a plasticity index that ranges from 36 to 46%, in which the higher the PI, the greater the potential for the problem. The building research establishment suggests that the plasticity index over 35% provide an indication of volume change in potential is very high. This volume change can give rise to the ground movement, which can cause damage to the buildings. Other than that, Batu Pahat soft clay have a problem of high settlement rate, which reduce the strength of workability and strengthen the design life of structure. In addition, soft clay are well known for their low strength and high constructability. Therefore, in order to prevent this problem, it is essential for engineers to stabilize the existing soil before commencing the construction activity. By stabilizing the soil, it is hoped that the soil will be more suitable as road subgrade and any road construction. In order to solve the problem of poor construction by using untreated soft clay, a research on the Batu Pahat soft clay is carried out to achieve the aim to determine the physical properties of the soft clay. Next, they investigate the compressibility behavior of soft clay treated by TX85 with SH85 probate stabilizer. The scope of this project is to improve the compressibility of soft clay using TX85 and SH85 probate stabilizer by doing testing at laboratory of UTHM and Research Center for Soft Clay Research. The selected stabilizer are TX85 liquid and SH85 powder soft clay sample from collecting research UTHM by depth of 1.5 meter to get The exactly soft soil. Physical properties of soft clay is determined by testing of Attenborough-Fine limit and standard Proctor test. Meanwhile, the compressibility of the soil is determined by conducting odometer test by following the percent of stabilizer mixture specified.
For my part is literature review. In this chapter, there are various categories such as soil, soft clay, chisel stone, soil compressibility behavior, primary statement, secondary settlement, third settlement, graph consolidation, soil stabilization, mechanical stabilization, chemical stabilization, and probate system will be discussed. Firstly, soil. Soil is one of the most important resources in terms of sustaining human development. Soil is a mix of organic matter, mineral gas, liquids, and organisms that together support life. Its importance lies in its role with air and water resources and the recycling of energy. More directly, it is important for plant growth including. For next is soft clay. Soft clay are typically characterized as soil with low shear strength, high compressibility, and low permeability. The shear strength of the soil is reported to be less than 40 kPa and it can be physically shaped with light finger pressure. Generally, soft clay in Malaysia is considered as quaternary. Sediment consists of alluvial deposits and organic light as peat soils. Soft clay, usually found in the coast plains of the country, covers large area of west coast and east coast of Peninsula and East Malaysia. For Batu Pahat soft clay, the Batu Pahat soft clay of University Tun Hussein on Malaysia were low in shear strength, bearing capacity, and suffer large settlement when subject to loading. Most of the building in UTHM required high cost in piling works because of the weakness and high moisture content of the soil, which can cause major settlement. Batu Pahat soft clay has really high liquid limit, cause it to become soft and sticky until it cannot retain in shape when it is described as being in liquid state. Next, chemical stabilization. These are various chemical stabilizers that can be asked to conduct experiments like this, including Portland cement, lime stabilization, fly ash stabilization, stabilization with lime flash, and lime cement fly ash. While the chemical stabilization that we will ask in our experiments are TX-Actify sodium silicate liquid soil stabilizer and SH-Actify biomass silica powder soil stabilizer. For TX-Actify sodium silicate liquid soil stabilizer, these additives are a low-cost alternative to traditional building material and have a different composition. They are also different from each other when interacting with the soil. Accordingly, the objective of this research is to investigate the strength properties and relate physicochemical mechanism of tropical lateral soils combined with TX-Actify liquid stabilizer. For SH-Actify biomass silica powder soil stabilizer, the UCS test results show that addition of SH-Actify powder had a significant stabilizing effect on the laterite soil, with the UCS value increased fivefold after a 7-day curing period. This research study confirmed the potential of SH-Actify as an alternative to traditional stabilizers for construction involving soil tropical waste. Alright, for theory of consolidation, consolidation is a process by which soils decrease in volume. It occurs when stress is applied to a soil that causes the soil particle to pack together more tightly, therefore reduce volume. When this occurs in a soil that is saturated with water, water will be squeezed out of the soil. The magnitude of consolidation can be predicted by many different methods. The odometer test. The test specimen is the form of a soil disc held in a metal ring and placed between two porous stones. The upper porous stone, which can move in the ring with small clearance, is mounted under metal loading cap through which pressure can be applied to the specimen. The entire assembly is located in an open water cell to which the pore water in the specimen has free access. The results are presented by plotting the specimen thickness or void ratio at the end of each increment period against the corresponding effective stress. Effective stress can be plotted on either a natural or logarithm scale. Although the latter is usually adopted due to the reduction in volume change in a given increment as the total stress increase. If desired, the expansion of the specimen can also be measured under successive decrease in applied pressure to observe the swelling behavior. For the stress history, the relationship between void ratio and effective stress depend on the stress history of the soil. If the present effective stress is the maximum ever experienced by the soil, the clay is said to be normally consolidated. Excessive consolidation is usually caused by geological factors. For example, erosion of the overabundant, melting of ice sheets after glaciation, or a permanent rise in the water table. Overconsolidation may also occur due to man-made processes. For example, the demolition of oil structure to redevelop the land will remove the amount of stress exerted by the foundation of the building that cause folding, so that for redevelopment, the soil will immediately by over-consolidate. For Terzaghi theory of the one-dimension consolidation, Terzaghi developed an analytical mode for determining the degree of consolidation within soil at any time. The assumption made in the theory are the soil is homogeneous, the soil is fully saturated, the soil particle and water are incompressible, compression and flow are one dimension. The coefficient of permeability and the coefficient of volume compressibility remain constant throughout the process. There is a unique relationship independent of time between void ratio and effective stress. For secondary compression, in Terzaghi theory, it is implied by assumption that change in void ratio are entirely due to a change in effective stress caused by excessive pore water pressure dissipation, with permeability alone controlling the time dependence of the process. The rate of secondary compression is thought to be controlled by the highly viscous film of observed water surrounding the clay mineral particles in the soil. The magnitude of secondary compression occurring over a given time is generally greater in normally consolidated clay than in over-consolidated clay. For rate of consolidation, the rate of consolidation for homogeneous soil depends on the soil hydraulic conductivity, the thickness and the length of the drain path. A soil with hydraulic conductivity lower than that of our current soil will take longer to drain the initial excess pore water, and settlement will proceed at a slow rate. For vertical drains, the slow rate of consolidation in saturated clay of low permeability may be accelerated by means of vertical drains, which shorten the draining pipe within the clay. Consolidation is then due mainly to horizontal radiant drains, resulting in the faster dissipation of excess water pressure and consequently more rapid settlement. Vertical drain become of minor importance. In theory, the final magnitude of consolidation settlement is the same, only the rate of settlement being affected. For previous research is divided into two, namely estimation of primary compression index using physical properties of Pontianak soft clay and consolidation properties of compact soft soil stabilized with lime silica film mix. For estimation of primary compression index using physical properties of Pontianak soft clay, primary compressibility parameters of the soil can be evaluated by laboratory tests, for example, which and time consuming and costly. Estimation of the compression index using the physical properties of the soil is fast and easy. Some research present a linear correlation between CC value and physical soil properties such water content, leakage limit, and void ratio. In this paper, linear regression method is asked to correlate physical properties of Pontianak soil to obtain compress index. Correlation between compressibility index as dependent variable and void ratio, water content, liquid limit respectively as independent variable is presented. For consolidation properties of compact soft soil stabilizer with lime silica film mix, the pre-consolidation pressure of a soil is defined as the highest stress the soil ever felt in its history. This is result of pozzolanic reaction taking place with lime silica film treatment, which result in the formation of calcium silicate hydrates and lead to increased strength. This implies that the stabilized soil will be able to withstand increased pressure without settling at higher stabilizer content.
For the research methodology, the research is about to improve the compressibility of batu pahat soft clay using TX85 with SH85 pro-based stabilizer by doing a testing at laboratory of University Tun Hussein on Malaysia and Research Center of Soft Soil. The method for the research used is physical properties test. The physical properties test was used to acquire the value of batu pahat soft clay. For the flow chart of methodology, for the first step, we must identify the problem. After that, we must do the literature review. And next, we must do the lab test. For the lab test, there are two types of tests that will be done for this research to get the physical properties, which are Atterberg limit, plastic limit and liquid limit, and standard proto test. This test was conducted in the laboratory of University Tun Hussein on Malaysia and Research Center for Soft Soil to obtain the physical properties of soft clay. After do the test for physical properties, the consolidation test will be done to investigate the compressibility behavior of combination between TX85 with SH85 treated batu pahat soft clay. For the sample preparation, there are 3 specimens have been prepared for the same mixture to get an average data. All specimens at different curing period 0, 7, 14 and 20xt with different percentage of TX85 with SH85. Progress stabilizer were made is 3% liquid plus 6% powder, 3% liquid plus 9% powder, and 3% liquid plus 20% powder. Then, the constant mass of the sample was compact into the ring. After remolding, the specimen will be sealed tightly in plastic sheet to prevent loss of moisture due to surface evaporation, and then cured at room temperature for 7, 14 and 20x day curing, and test at no curing for 0 days. After that, odometer test will be done with that specimen, and data will be collected and inserted to the table, and analysis will be carried out. So, this is the table for the consolidation test for preparing sample. Now, let me tell you what is the procto-compaction test. The procto-compaction test is a laboratory geotechnical testing method used to determine the soil compaction properties, specifically to determine the optimal water content at which soil can reach its maximum dry density. And this is the example apparatus for procto-compaction test. Now, let me tell you what is the standard odometer test. The standard odometer test is used to consolidation cell of saturated soil. Odometer test dimension of usually 75 mm diameters and 20 mm thick are used. And this is the example apparatus for the odometer test.
Expected result from our project is physical properties of soft clay can be determined by carry out physical property test, Atterberg limit and Proctor test. Next, consolidation behavior of soft clay is expected to be decreased in settlement after treat by combination between TX85 and SH85 according to the increase of SH85, proportion and curing respectively. The void ratio is expected to decrease as combination of TX85 with increased percent of SH85 that fill the void between particle of soft clay. Other than that, this research fulfill to need of the person who involved on the road design and construction. Is also hope to give an alternative idea to highway engineer and contractor in respect of stabilization of on-road subgrade.
For the conclusion, this research aims to determine the physical properties of soft clay and investigate the compressibility behavior of TX85 treated soft clay with SH85 progress stabilizer. Based on the physical properties test done, we can determine the physical properties of soft clay and can investigate the compressibility behavior of soft clay treated by TX85 with SH85 progress stabilizer. Thank you.